Hey everyone, and welcome back. Ready to dive into another research rabbit hole with me?
Always up for a deep dive. What have you got for us this time?
Well, get this. We're talking about computers that can understand human emotions from your voice.
Oh, wow. Like, actually tell how you're feeling just by your tone. That's speech emotion recognition, right? SER.
Exactly. And you know how most tech seems to focus on just English? The research we're diving into today tackled multiple languages.
Seriously. That's a whole other level of complexity.
Human emotions are tricky enough, but then you add in the nuances of different languages.
Right, like a sarcastic, yeah, right, in English is going to sound totally different in German or Arabic. So how do you even begin to teach a computer about something as subjective as human emotion?
Well, it's all about those subtle cues hidden in our voices. Things like pitch, tone, even how quickly our voices fluctuate. The research breaks those cues down into measurable features.
It's like giving the computer a crash course in emotional intelligence, but for audio. Exactly. They focused on three main audio features. First up, zero crossing rate, or ZCR. It measures how often your voice crosses that 0 point, from low to high frequency.
So a whisper would have a low ZCR, while a shout would have a high one. Makes sense. What else are they looking at?
Then we have RMSE, which stands for root mean square error. It's basically a way to measure the energy in someone's voice.
Okay, so high energy could mean excitement, anger, those sorts of emotions, while low energy might point to sadness or boredom.
You got it. And the third feature they looked at is called Mel Frequency Cepstral Coefficients, or MFCCs for short.
MFCCs. Catchy name. What do those tell us?
Well, MFCCs are really interesting because they're all about mimicking how our ears and brains process sound. Our ears are naturally more sensitive to changes in lower pitches than higher ones, and MFCCs take that into account.
It's like giving the computer an ear for emotion, literally. They can perceive those subtle shifts in our voices the way another human might. So they've got these features, ZCR, RMSE, and MFCCs. What do they do with them? How do you build a model that can actually understand emotions based on that?
That's where things get really cool. They use these features to train not one, but two different models.
Two models. Okay, now you've got my attention. It's like a battle of the algorithms.
There really is. The first model they tested uses something called a 1D convolutional neural network, or 1D CNN for short.
A 1D CNN. Okay, break that down for me. What's so special about it?
Well, imagine you're listening to a piece of music. A 1D CNN is kind of like having a friend who can listen to that music and hear not just the individual notes, but how those notes flow together over time to create a feeling.
So it's like it can feel the emotional arc of the music.
Exactly. But in this case, instead of music, it's analyzing the melody of someone's voice.
Okay, so it's looking for those patterns in our speech, those subtle shifts in tone and energy that might reveal how we're feeling.
You got it. And to make things even more interesting, they combined this 1D CNN with something called long short-term memory, or LSTM.
LSTM. I feel like we're getting into some seriously advanced computer science here. What does LSTM bring to the table?
Think of LSTM like giving the computer a super-powered memory. It can remember those crucial emotional cues from earlier in the conversation, even if the speaker changes their tone later on.
Okay, so even if I try to mask my true feelings, this LSTM is like, nope, I remember that slight tremor in your voice from 5 minutes ago. You're not fooling me.
Exactly. It's all about capturing those fleeting emotional nuances that we might not even consciously pick up on as humans. And hold on, because it gets even cooler. They added one more ingredient to this model, an attention mechanism.
An attention mechanism.
Yeah.
Is this like giving the computer a dose of emotional awareness?
In a way, yes. Imagine you're having a conversation with someone and they mention something that suddenly piques your interest. Your attention focuses, right?
Yeah.
You hone in on their words, their tone, their every expression.
It's like that moment when you can tell something's up, even if they're not saying it outright.
Precisely. That's what the attention mechanism does for the model. It helps it focus on the most important parts of the audio, the parts that are most telling of the speaker's true emotions.
This first model sounds incredibly complex, like they threw everything but the kitchen sink at it. What about the second model?
Well, for the second model, they went with a different approach, using something called a 2D CNN.
A QD CNN. Didn't you say those are usually used for image recognition? Like teaching a computer to tell the difference between a cat and a dog in a photo.
You're exactly right. 2D CNNs are great at spotting patterns in images. But here's the really clever part. They found a way to convert those audio features we talked about, the ZCR, RMSE, and MFCCs, into a visual representation.
So they turned sound into images. That's wild.
It is. They basically created a visual heat map of someone's voice, with different colors and shapes representing the different acoustic features. And then they let the 2D CNN loose on those visual patterns.
So we've got two very different contenders here. One that analyzes emotions based on the patterns of speech over time, and another that looks for emotional cues in a visual representation of the audio. Fascinating. But the real question is, did these models actually work? Were they able to accurately recognize human emotions from speech?
That is the million-dollar question, isn't it? And the answer is, well, they got some pretty amazing results.
All right, spill it. How did these emotion detecting models perform? Did they pass the test?
Well, remember that first model, the one with the 1D CNN, LSTM, and the attention mechanism? It really knocked it out of the park. When they tested it on that German data set, EMODB, it got a 96.72% accuracy rate.
Whoa, 96.72%. That's incredible. It's like it can practically read minds.
Right, and it gets even wilder. With the English data set, SAVE-E, it did even better. We're talking 97.13% accuracy.
Okay, now that's just mind-blowing. Imagine if our phones could understand our emotions with that level of accuracy. It could totally change how we interact with technology. But what about the Arabic data sets? Did those models keep up their winning streak?
That's where things get really interesting. For the NAD and BAVI data sets, the accuracy was a bit lower, but even with a slightly lower accuracy, it's still a huge accomplishment, especially when you consider how complex human emotions are, let alone trying to recognize them across different languages.
It makes you wonder if maybe some emotions have more universal acoustic patterns, while others are more specific to certain cultures or languages. What about those individual emotions within each data set? Anything stand out there?
Definitely some interesting findings. For the NAD dataset, which focused on anger, happiness, and surprise, the model was particularly good at recognizing anger.
Interesting. So it was really tuned into the specific ways anger is expressed in Arabic speech. It makes you think about all the subtle vocal cues we might not even be aware of.
It's true. And, for the English dataset, SAVE-E, the model was most accurate at recognizing happy, surprised, and neutral.
It's interesting that those three emotions cluster together. It makes you wonder if certain emotions just have more in common, acoustically speaking, regardless of the language.
It really does. It shows just how much more there is to learn about the nuances of emotional expression. And then there's the German dataset, EMODB. Disgust, and once again, anger were the most accurately identified emotions there.
So we've got anger coming out on top in both Arabic and German, happy is shining through in English, and disgust is making a strong showing in German. Fascinating. It's like each language, each culture might have its own unique emotional fingerprint.
Absolutely. It really makes you think about all the different ways humans communicate and express themselves.
This research is incredible. Thanks for taking this deep dive with me. I always learn so much from our conversations.
Anytime. It's always fun to explore these fascinating topics together.
And to our listeners, thank you for joining us on another deep dive. Until next time, keep those brains curious and those conversations flowing.